here are the problems for the answers for those last 4 problems that were on the notes. So check those real quick. And then we'll go over a few of those. Okay, so I want to go over the first 2 because, again, I want you to be able to show me work for the conversions. So those of you in chemistry, hopefully you find this simple. Those of you who have not taken chemistry yet, you may not have been taught to do it this way, but this is a good way to do conversions. So what is the conversion between kilometers and meters? What is the conversion factor?
1,000 meters equals 1 kilometer.
1 kilometer is 1,000 meters. Okay, so that means that we're going to multiply by 1. Maybe. In a special format. So you know that if you multiply a number by something other than 1, it's going to change the number. But because we're multiplying by 1, that means we're not changing the number, we're just changing the way that it looks. So there's 1,000 meters in 1 kilometer. I want kilometers on the bottom in order to cancel the kilometers on the top, and I want meters on the top to divide out with the meters on the bottom. So 1 meter is equal to, 1 kilometer is equal to 1,000 meters. And then we can cancel meters, we can cancel kilometers. And then we're multiplying straight across because we're multiplying fractions. So top, top, bottom, bottom. And that will give us 5,000 on the top, 200 on the bottom. And then you can divide out 100. 50 over 2 is 25. If you wanted to do the simplifying back here, you know, like divide it out that way, you can, but if there's too much happening, sometimes you like lose numbers or get yourself confused. So just make sure you're not trying to do too much at once and, you know, making mistakes. Okay, what is the conversion factor with ounces and pounds?
16 ounces to a pound.
16 ounces and 1 pound. Okay, so Lucy, should ounces go on the top or the bottom?
They should go on the bottom.
They should go on the bottom. So we want ounces to be done here. We want pounds on the top. I'm going to write this like pound because my lowercase b tends to start looking like a 6. And since we've got 16 ounces in 1 pound, I don't want that to be confusing. Okay, so I'm going to cross out pounds, divide out ounces, and then again, we're multiplying straight across. So anything on the top and anything on the bottom would cancel, but I'm going to go ahead and, because the numbers aren't really that big, 40 over, that's 80, is equal to 1/2. Okay, so when you're doing the conversions, I want to see work like that. You can also do a substitution type of thing. So if any of you have done it where you do something like 5 kilometers over 200 meters, and then sort of like substitute, In place of kilometers, you're putting 1,000 meters and 200 meters to cancel out the meters. You can do something like that, but I just want to make sure you're able to show me steps you're not trying to do in your head. Okay, you need to make sure you can show steps. Does anybody have questions about the second or the third or the fourth problems? Those two problems? Okay, we're going to do some practice with solving those, like setting up ratios and simplifying and whatever. But the first thing I want you to do is go to Schoology, and you can either go to today's folder or you can pull it from the homework on the side. Homework number 16 is our notes for today and also finishing for homework. So it's kind of like, you know, an all-in-one. It's just all lumped together. So when you import that, it's going to be homework number 16 and lesson 7-1, day 2. On quadratics. And if it ever opens, we will start doing notes. Okay. Maybe. All right, so if you take a look at this, the first page, we're going to do a lot of those problems together. The second page you'll be doing almost completely on your own. And then later in this class, we'll do lesson 7-1 skills practice. I'll have you do those and we'll check those, and then you'll have to do this page for homework. Okay, so first of all, on the second page, let's just look at these problems that are down at the bottom of the second page. How do you simplify something like 8 books over 24 books?
Divide by 8, or divide by 8 over 8, which is the same as dividing by 1.
So books will cancel out, right? Because we're in the same units this time. And we're dividing an 8 out of the top and bottom. We're just simplifying, right? So it'll make it 1/3. Notice that there's no label there. And also don't round these ever. You want to leave these in fraction form. Okay, same thing on the second one. Trees is the same unit, so it can just cancel out. And then if you simplify that, divide by 2, be 12 over 7. No labels on those. And then the ones down here are going to be the kind like we were just doing. So those are, you have to know the conversion and do the multiplication. Okay, let's go up to the first page. And we're going to talk about quadratic formula today. So I know you saw this last spring, but we're going to make sure that we remember how to use the quadratic formula. Sometimes when you solve, in the middle of page 1 here, sometimes when you solve proportions, so like this would be 8 times x plus 2 is equal to 4x times x. And if I distribute on the left side, we've got 8x plus 16. What would the right side be?
Wouldn't it be 4x squared?
4x squared. So sometimes when you solve proportions, you end up getting a quadratic, you get an x squared term, and that's why we're reviewing the quadratic formula here. So I'm going to start by doing some basic simplifying, because the answers that you get will often turn out to look like this kind of situation here. Okay, so when you're simplifying those, you want to look at the numbers that are on the outside of the radical. And these are the numbers that you're allowed to simplify. You're not allowed to touch the radical 2. The 2 underneath there is protected by the radical sign. So unless you're able to simplify that radical and pull something out, there's nothing you're going to be able to do with that 2 in there. Okay, so what can you divide out of those numbers?
3.
3. That's the greatest common factor. Okay, so we're going to divide each of those numbers by 3. Now, when you do that, Lily, tell me what you're going to get when you divide out 3.
It'd be -1 plus or minus 2 root 2 over 6.
Okay, you don't sound very confident.
Well, I get it now. I was just confused at the beginning.
Tell me why we need that -1. Why does that -1 have to be there? Why doesn't it cancel out? Why isn't it this? You're right. But how did you know to put a -1 there?
Well, -3 divided by 3 is -1.
Yeah, it didn't disappear, right? If I say simplify -3 divided by 3, you're not going to say 0, right? And if you don't put that there, that's a 0. So that's kind of a common mistake. Sometimes students like quote cancel it out and make that disappear, but that's not going to disappear. It's going to become a -1. Is there anything else that we could do there? Are you allowed to divide the 2 and the 6? This is for anybody. This doesn't have to be Lily. What do you think? Allowed to divide the 2 and the 6?
Yes.
Yes. Unfortunately, anything you divide out of the bottom has to come out of all the terms on the top. So you still have to be, anything you take out of the 6 has to come out of both of those numbers. Now, sometimes it bothers students that they see that 2 and that 6 and they feel like they should simplify. This is your final, like I'm perfectly fine with you leaving your answer in that form. But in Algebra 2, you might, and those of you that are doubling, you know that sometimes you write your answers like this. That answer that I highlighted is the same thing as saying -1/6 plus or minus, and if I divide the 3 here, now because it's its own term, it'd be square root of 2 over 3. So when you look back at kind of the original problem, that is a -1/6, and that is a 1/3, right? Which is what that is, 1/3. So that, again, that number in the front here cannot divide out because look, it's not going to disappear because it's representing an actual part of the answer. If you don't put anything there, it would be 0. If there's nothing there, it's understood to be a 0. And 1 plus 2 root 2 over 6 is not the same thing as 0 plus 2 root 2 over 6. Okay, so you have to make sure that you are careful when you're simplifying these. All right, thoughts for, and again, I'm fine with you leaving the answer like that, but that is the same thing as this. So if you see simplified answers that look like that, it's the same thing. Okay, Rachel, tell me what you would do first for the next problem.
Would you divide by 5? Because that's the GCF.
Remember how I said that you got to work with the numbers on the outside of the radical? What number is sitting out here in the front?
0.
If it was 0, what's 0 times the square root of 75?
Oh, 0.
Yeah, so it's not 0. What is it?
Is it 1?
It's 1. It's just like if you have an x, how that's really a 1x. There's an implied 1 in the front there. So you have to be careful because you're only allowed to work with the numbers that are on the outside of the radical. Okay, so Rachel, you have an idea of what we can do before we try to divide?
I don't know.
That's okay. Alexis, what do you think?
Simplify root 75.
Okay, how does that simplify? Remind me how to do that.
You can divide it by 15 and 5.
So you could do a factor tree, right? And then the numbers that get paired up come outside of the radical, and then the other numbers stay inside. You can also do the kind of perfect square method. Can somebody tell me another way to break that down without doing a factor tree?
25 times 3, and then you have the 5 because it's the square of 25. So it'd
Yes.
be 5 root 3.
Right, 25 is a perfect square that goes into 75. So if we make it 25 square root of 25 square root of 3, that's 5 root 3. So whichever way you prefer, either of those is fine, but just make sure you remember how to break down those radicals. Now, again, we have to do that first because there's no number outside of the radical 75 that we can divide out with the 20 and the 15. All right, so that's going to give us 15 plus or minus 5 root 3, all divided by 20. Jack, what do you think we should do next?
Divide 15, 5, and 20 by 5.
Okay, now we can take out a GCF, right? So let's go ahead and divide those by the GCF, which is 5. And what does that give you, Jack?
3 plus or minus square root of 3 over 4.
Over 4. Okay, I heard square root of 3. So tell me why you're not sure about that term.
Because I was thinking whether you needed to put a 1 in front of it or not.
Okay, so you are confident that it doesn't divide out, but you're wondering if you need to put like a 1 like that.
Yeah.
Okay, it's not wrong to put it, just like if you have X, when you put a 1 and X in the front, it's not wrong. It just looks kind of weird to people that, are comfortable with radicals. So that's perfectly fine to do that, but you don't have to have it. There's an implied 1 in front of the radical, again, just like with variables. So again, if you wanted to think of this like 15 over 20 plus or minus 5 root 3 over 20, okay, you'll see right here is 3/4. And then right here is root 3 over 4, or 1 root 3 over 4. So it's the same idea down here. You can either simplify that like 1 root 3 over 4, or you can just say cancel that out and it's root 3 on the top and 4 on the bottom. So again, I'm perfectly fine with you leaving it in this way. I think in algebra 2, if you get imaginary numbers, they make you split it up maybe in the 2 parts, but this is fine for what we're doing. Okay, so some of the problems, there's 3 problems on this page that we're not going to do together. And so you need to circle it, put a star by it, highlight it, do whatever you need to do to make sure you don't overlook which problems you need to do. So however you want to mark that, put a circle around it, put a star on it, put arrows, right, do this, right, homework, whatever you need to do, make some kind of note to remind yourself that you need to do that problem later. Okay, we're going to do the quadratic formula, which the quadratic formula is negative b plus or minus the square root, b squared minus 4, the quantity b squared minus 4ac, the whole entire thing over 2a. Okay, and that formula gives solutions to a quadratic equation in this form. Notice that it has to be equal to 0. And the a, b, and c in the formula refer to the number that's the coefficient of x squared is a, the number that's the coefficient of x is b, and then the constant is c. Okay, so the a, b, and c there is assuming that you've put it in what's called standard form, where you have the x squared term, then the x term, then the constant. Okay, we kind of already did that first step on this one. So we're gonna go ahead and cross multiply. You don't have to show me this step here. If you want to do that in your head, that's okay. Just be careful you don't forget to distribute when there's sums and differences there. Sometimes that, gets messed up. Okay, so Zoe, tell me what you would do next.
I would subtract the first side by 4x squared.
Okay, there's nothing wrong with making this negative 4x squared, blah, blah, blah. I'm going to, it's kind of a common thing to leave the number in front of the x squared to be positive. What I just said about standard form, you're supposed to have the a value positive. So it's fine to do what you said, and your work would look a little bit different than mine along the way, but in the end, it would come out to be the same. I'm going to leave the 0 on the left side and subtract the 8x and the 16. But the point is you have to get it equal to 0. So whichever side you want to collect the numbers on, it really doesn't matter. It'll work out either way. Okay. Any thoughts about what you should do next?
Divide by 4 on both sides to simplify it.
Okay, so if you don't do that, will a quadratic formula give you correct answers? Yes. Will it be more difficult? Yes. If you go plug those numbers in right now into the quadratic formula, there's going to be a lot more, like there'll be bigger numbers. There's going to be a lot more simplifying, especially underneath the radical sign. You'll have a larger radical to reduce and whatever. So if it is possible to simplify the equation by dividing out a common factor, then do that. It's just going to make your life easier when you go to plug the numbers in. Now 0 over 4 is still 0. But that's going to make that now x squared minus 2x minus 4. Now, if you try to factor, it would turn into, we know we need x and x. And we would need two numbers. Remember that the last value is your product. So this would be the number that's the product of the two numbers you're going to fill in. And this is your sum. So we know that to get a negative product, we would need 1 minus and 1 plus. Our options are 4 and 1. Now, because the signs I've got there, 1 and 4 would be different, right? Or 2 and 2. And none of those numbers, none of those combinations are going to add to give us a negative 2, whether we put a negative here and a positive there or vice versa. Okay, so it's not factorable. And that's why we're using the quadratic formula. If a problem is factorable, then solving by factoring and solving by quadratic formula will give you the same answer. Typically, factoring is easier, not always, but if I'm telling you to solve by quadratic formula, that usually means it's not factorable. Okay, so here's the quadratic formula again. I'm just going to grab that from up here and copy it down. Shrink this down a tad here. When you go to plug into the quadratic formula, what are we using for A, B, and C? Now, you don't have to do this, but sometimes writing down the A, B, and C will keep you from making mistakes instead of looking at it up in, you know, up where it is up here. Katie, tell me what the A, B, and C are.
A would be
4.
It's going to go in. Oh, look at the simplified form of it.
Oh, sorry. A would be 1. B would be 2, and then C would be, or negative 2, and then C would be negative 4.
Good. Okay, so if there's no number in front of the variable, it's understood to be a 1. Make sure you take the signs along with the values. If it said like x squared minus 4, what does that mean the B is? So A would be 1. What would B equal?
Wouldn't B equal 0?
B would be 0. So if there's a term not there, then it's 0. If there's just no coefficient on a variable, then it's a 1. If I put it like that, then B would now be negative 4. And there is no C term, so C would be 0. Okay, so A is 1, B is negative 2, C is negative 4. When you plug into the quadratic formula, think of that first term like the opposite of B. So since B was negative 2 to begin with, that means it's going to turn into positive 2, plus or minus the square root of the quantity, -2 squared, -2 the quantity squared, minus 4 times a is 1 and c is -4. All divided by 2 times a, which is 2 times 1. 2 plus or minus the square root of 4. What gets added or subtracted from 4? What's the sign? What will go there? Johnny, what's going to go after the 4? Square root of 4, what?
The square root of 4 plus 16.
It'll be plus 16 because you have a double negative. The whole thing divided by 2. Okay, so 2 plus or minus the square root of 20, all divided by 2. Now, let's simplify that. Leah, tell me what we can do then.
Simplify the radical 20.
Okay. How does that break down?
2, 10, and then 5 and 2. So then you'd have 2 radical 5.
2 radical 5. Again, you can also do square root of 4, square root of 5, which is also 2 radical 5. Whichever way you want to do that, it'll give you the same answer. And again, notice that we're simplifying the radical before we do any dividing. Oops, sorry. I'm talking and not paying attention. 2 root 5 all over 2. All right, Mark. Now what?
Divide by 2. So it comes out a square root of 5.
What happens when you divide 2 by 2? Is that 0?
It becomes 1.
So those numbers in the front there are all being divided by 2. It becomes 1 plus or minus.
Oh, wait, it'd be 1 plus, yeah.
Plus or minus what?
Square root of 5.
Square root of 5. Now, those of you that are not as comfortable with radicals, that's like what it actually is, right? But in a simpler form, if you write it like that, that's kind of the accepted form. And when you're first learning, not quite comfortable with radicals yet, you tend to write numbers that look a little weird to people that have already been doing radicals. So it's just like if you write 1 plus 1x, how, that looks weird to you now because you're so used to not seeing that 1 there. But it's not wrong to leave it like that. But it's the same thing as 1 plus or minus root 5. Okay, you're going to be doing this problem. So star, arrow, do this, note to yourself, make sure you don't overlook that one. Okay, and then we're going to do a quick solve by factoring here. So x times x minus 3 is equal to 18. And so x squared minus 3x equals 18. Sarah, what would you do next?
You would subtract 18 from both sides.
So whether you're factoring or doing quadratic formula, you need to get it equal to 0. That's either method, you get it equal to 0. Okay, and to Redeemer, are you able to factor that for me?
You would have a positive 6 and or you do write both x's.
So x times x is x squared. We need 2 numbers that multiply to what?
That give us negative 3x and 18. So would it just be positive 6 and negative 3?
So we're looking for a product of negative 18 and a sum of negative 3. So yes, positive 6 and negative 3. What if you had a minus with the 6 and a plus with the 3? Sorry, I don't mean that. plus with the 6 and minus with the 3. When you FOIL that out and you get x squared minus 3x plus 6x minus 18, what does that middle term give you?
Positive 3x.
Positive 3x. So if you're really close but the sign is off, you should be able to just swap the signs and it'll work out. We want the larger number to have the negative coefficient because when you add them, you're supposed to get a negative value on this problem. Okay, so 6 is the larger number. It needs to take the negative sign. All right, and then remember you say x minus 6 equals 0. So the number that zeroes out this factor would be 6. And then x plus 3 equals 0 means x equals negative 3. And those are your two solutions. If you use the quadratic formula, it would give you the same answers. Okay, but again, typically factoring is a little simpler. So if it's factorable, typically we'll do that. Okay, circle this one. You need to do that one for homework, and then we're going to do this problem here. When we cross multiply, we'll have 2x squared minus 40 is equal to negative 11x. Luke, what would you do next?
Add 11x to both sides.
So 2x squared plus 11x minus 40 equals 0. And then we're going to figure out how to break this down. Since 2 is prime, we know that we're going to have a 2x and an x. Now, you're still looking for two numbers that will multiply to negative 40, but this time their sum will not be 11 because the number that you put here has to get multiplied by 2 before it gets added to the middle product. Okay, so I'm going to come over here and list the factors of 40 just so we have some to work with. 1 and 40, 2 and 20, 4 and 10, 5 and 8. 6 and 7 don't go into 40. So if we wrap back around, we've got all the factors. Okay, then it's just a matter of really guess and check. What do you know about the signs of the numbers? What do you know about the signs?
Miss Hastings-Smith.
You gotta go.
Yes, I do. So just whenever you can, I would really appreciate the notes. Thank you.
Okay, so there are two numbers that will multiply to give you negative 40. What do you know about the numbers if it's a negative 40 product?
One of them's got to be positive and the other one's got to be negative.
One positive and one negative, right? So we know it's going to be a positive and a negative. It's like a little face. But on this problem, it's different if you put minus here and plus there versus putting plus here and minus there. And that's because those terms are different. Okay, so just keep in mind, you got to have a plus and a minus. But if you put like negative 1 and positive 40, that's going to be different than if you put positive 1 and negative 40. That's also different than if you put negative 40 and positive 1 or positive 40 and negative 1. So each one of those actually has kind of 4 different combinations that you need to be thinking about. So again, putting a 40 here means that that 40 gets multiplied by 2 before it gets combined with the negative 1x, whereas putting a 1 here means that 1 gets multiplied by 2 before it gets added to the negative 40. Okay, so for these problems where you've got opposite signs, that really does kind of give you more things to check. Now, I'm going to go ahead and start with 5 and, I meant to delete that. I'm going to go ahead and start with 5 and 8. What if I put 5 here and 8 here? Well, our middle terms are going to be 10x and 8x. And again, one will be positive and one will be negative, but it doesn't seem like there's any way to get 10 and 8 to give you 11, no matter what the signs are. So no 8 and 5. What if we try 5 and 8? These two together will give you 11x if the sign, which sign needs to be negative?
The 5.
Negative 5.
Yeah, so if we have a minus 5x, that means you want that to be negative, and you have 8 as positive, then do a quick mental check and make sure it makes sense. Okay, so 2x squared is your first. Your outer would be 16x. Your inner would be negative 5x. And your last would be negative 40. And then that does add to 11x. Now, again, if you got a negative 11x there instead, then that just meant that your signs here were incorrect. So just switch them around. Okay. If you know a way to do, because there are some algorithms you can use to do the problems where you have a leading coefficient. At Cathedral, we kind of feel like those algorithms tend to work when you're doing factoring, and then a month later when you're not in the middle of a factoring unit, you forget how the algorithm works and you can't do factoring anymore. So we really want you to try doing a guess and check kind of method. If you already know another method, you can do that consistently correctly. You can use another method like a factor by grouping type of thing or something. Okay. But I'm going to encourage you to do guess and check. Now this one, x plus 8, that looks the same as the other one that we did. So x equals negative 8. But that one, it does not look the same. Jacob, can you tell me how to solve that one for the x value?
What should be 2x minus 5 equals 0?
So x is what?
2.5.
Yeah, 5 halves or 2.5. So when there's a coefficient in the front here, it's not just going to be x equals 5, right? It's going to be x equals 5 halves. So just kind of watch out for the ones that have the leading coefficient in the factor. It's not going to be just the opposite of the number in at the end of the parentheses there. Okay, so again, on page 1, you've got those 3 problems to do. And then you'll be finishing page 2. And right now, I'd like you to take, I'm going to give you about 5 minutes or so. I want you to work out the problems on the 3rd page that say 7-1 skills practice. I want you to work those out and then we'll check them just to make sure that you're comfortable with like doing those problems, because the 4th page is the same kind of problems. Here are the first 5 answers. Notice that number 2 is 1 to 2, not 1 to 3. It asks you to compare elective to non-elective. So if she has 2 electives out of 6 classes, that means she has 4 non-electives. You're not comparing elective to total. You're comparing elective to non-elective.
Mrs. Hastings-Smith?
Yeah.
Are you allowed to leave it as a fraction?
Yes. You mean like 1/2?
Yeah.
Yes. So I wrote it like that because sometimes students want to write it that way, but I'm perfectly fine with fractions. Fractions are usually easier to think about when you're using them in the context of a, like a problem. With problems like 4 and 5, I really do want you to make little proportions. And I know that sometimes the numbers are simple and you think, I'm just going to do that in my head. But I want you to get in the habit of writing proportions. So when the numbers aren't simple, you feel confident that you know what you're doing. I understand that you don't necessarily have to cross multiply in a problem like this. If you can look at that and say, oh, 4 goes into 125 times. So if I multiply the bottom by 25, I'd have to multiply the top by 25. So x would be 25. Or like on the next one, the ratio of male to female students is 3 to 4. 3 goes into 18 6 times. So if you multiply 4 by 6 also, that gives you 24. Okay. And then I don't remember which numbers I crossed out from 6 through 11. The answers are all there, but you can just check the ones that are not crossed out. Any questions on anything on this page? Okay, so page 4 is really similar to that page. So again, for homework 16, you're doing 3 problems on page 1, all of page 2, except for the couple we did, should be done. And then you should be done with with the 7-1 skills practice on page 3. So then make sure you do page 4. Again, just the ones that are not crossed out.